Welcome to my channel, viewers, and this is the second video of second module of the my accounting exam paper, which I made this. Okay, and in my first video of this module, we have solved 15 problems, and the lecture here is this. Now first we have to follow the question number 16. Okay, see, and this is there 16. Okay, and y is equal to, and this is their cos inverse, and 5 cos x minus 12 sin x by 13. So that's why, as this is a cos inverse, we want to convert this as a whole thing as a cos of something. So that's why we have take a 5 as r cos alpha, and this is 12 as a r sin alpha. Now 5 square plus and 12 square, and this is equal to r square, and therefore r is equal to 13. So if we put this and cos inverse like r cos alpha and cos x minus r sin alpha and sin x and by 13. So we have to take a common r by 13, and cos a cos b sin a sin b, and this is here, and cos of x plus b, and this is r is equal to 13 here. Okay, so 13 are cancelled, and cos inverse cos we get here, and this is as a x plus alpha, as 5 equal to r cos alpha, 12 equal to r sin alpha, so alpha is a constant. So that's why if we differentiate this, dy by dx is equal to 1, we get here, and the option number A. Okay, and now 17. Now 17, follow the question number 17 here. X to the power y and y to the power x is equal to 16. If we take and we have to find the dy by dx. So as it is a product for a pattern, we have take a logarithm on both sides. So y log x and x and log y, and this is log 16. So differentiate both sides, and then we get here, if we differentiate, this is 1 by x, and now log x and dy by dx, and x and log y, this is 1 by y, and also can be written as dy by dx, and this is log y, and differentiation of x is 1, and log 16 is 0 here. And now at 2 comma 2, so we have to want to find the value of that at 2 comma 2, and it is given that this is 2 comma 2, so 2 by 2 plus log 2 dy by dx, and this is 2 by 2 and dy by dx, and this is log 2, this is y, log 2 equal to 0. So from that we can write 1 plus log 2, and this is minus dy dx, and also here log 2 plus 1, and this is a cancel, so dy dx is equal to, and at 2 comma 2 is here minus 1. Okay, and this is 17. And now follow the 18. Okay, very interesting question. X is equal to tan theta plus cot theta, and now take a LCM like tan theta are 1 by tan theta actually, and this is here tan square theta, now minus x tan theta, and plus 1 equal to 0. Therefore tan theta is equal to b root over b square minus 4ac by 2a, and from the same as y is equal to tan to the power n theta and cot to the power n theta, we can write here tan to the power n theta, and is equal to y plus minus root over y square minus 4 by 2 here, and take a sign positive. So like that, tan theta is equal to x plus root over x square minus 4 by 2 here, and tan to the power theta to the power n is equal to y plus root over y square minus 4 by 2 here. Okay, and therefore x plus root over x square minus 4 by 2 to the power n, and that is y plus root over y square minus 1 by 2. Okay, and take a logarithm. So we can write here n, and x plus and root over x square minus 4. And actually this is here 2 to the power n, and this is 2 to the power n minus 2. We can write here 2 to the power n minus 1 and plus logarithm of y plus root over y square minus 4, and this is 4 here actually. Okay, and you can write 4. So differentiate both sides with respect to x. This is n by x plus root over x square minus 4, 1 plus 1 by 2 root over x square minus 4, and this is there twice x, and same as this is 0, and now and this is 1 by y plus root over y square minus 4, 1 plus twice y, and this is root over y square minus 4, and this is 2, and dy and dx. So now if we take here LCM, so we get here n by root over of x square minus 4, and this is here 1 by root over of y square minus 4 and dy dx. So from that we can write here, so I am squaring both sides, so this is x square minus 4 y1 square, okay, and this is n square into y square minus 4, okay, and differentiate this, we get here x square minus 4 twice y1 and y2, y1 square, and this is twice x, n square twice y and y1, and take upon 2 y1 and cancel this, then we get our required statement, and this is x into y1, and this is n square into y, and take a left hand side on this, will get this, okay. Next problem is that is 90. See, this is f of x is equal to small f of x and phi of x, and also given that the f dash x and phi dash x is equal to, actually this is phi dash x is equal to a, and if we differentiate this f of x and phi dash x, okay, and this is phi of x and f dash x, and doing u into v, this is f of x and phi dash x, and this is a unchanged f dash x, again phi of x, this is f double dash x, and phi dash x, f of x and phi dash x, these two are same. So now divided by f dash x by f of x, and this is here f of x phi dash x, phi of x, f actually double dash x, and this is 2 times of this as a which is given, and f of x is equal to f of x and phi of x, this divided by this is phi double dash x by phi of x, this divided by this, these are cancelled, so f double dash x by f of x, and this is twice a by f of x and phi of x, okay. So actually this is the option number D here is perfect. See carefully, okay. Now next problem 21. This is a y equal to x to the power sin x and log to the base sin x, and this is x, and this is variable to the variable. You can write here e to the power log of x to the power sin x to the base e, and you can write like that, changing the base here, okay, and you can write sin x and log x to the base e and log x by and each of them to the base e here. So differentiate this dy dx and we get same as and this figure, and also differentiate this as a u into v. So sin x, differentiate log x by x and log x to the base is, and this is s cos x, and this is u by g, and this is a whole square 1 by x, okay, and this is being here minus, actually this is the formula, log x to the base e, and derivative of log sin x 1 by sin x, and sin x, this is cos x, okay, and we can write this is as a x to the power sin x by x cos x, okay, and plus this divided by this 1 by x log sin x to the base e, and this is log x into cot x. Okay, this is the 21st. Okay, see carefully. Okay, now we have to proceed to the 22. See, and this is 22. It is given that the integral 0 to 1 f of x and g of x, and 0 to 1 g of x and dx. Question is that the function is always same or not. Actually, according to me, we have to show the it is not possible when the integral are same, then the function is always same. It is not possible. Now let us assume as a, that is, you can choose like that. It is not a learning point. Okay, you have taken as a twice x plus 5 and 3x plus 7, like 7x square plus 5. That is your choice. And okay, and g of x you should use as a unknown constant like x cube here. Okay, now put this function on this two integral, and what happens, see, and this is 0 to 1 k x cube and dx. This is 2x square by 2 and 3x. This is 0 to 1 and this is k. So x to the 4 and this is 0 to 1. And now this is 1 plus and 3. This is k into this is 1 by 4. And now k equal to 16. Now put on the function, therefore f of x, sorry, twice x plus 3, and g of x is here 16 into x by 3. So see, the function are not same here, but the integration result are same. So not inverse and true. When the integral, definite integral are same, so function cannot be a possible, both are equal always. Okay, 1 to e log x to the power m, and now and see, im is equal to this is 23rd, and given that im with the limit of 1 to e log x to the power n, and this is the dx, and now without we have to take another function, this is im to the power m and dx, and we can use as a u into v, so log x to the power m dx, and if we differentiate this, so m into log x to the power n minus 1, and this is 1 by x, and integrating ds. Okay, so x if we put here e, so log is 1, so it is 1, and c, and the notation here is m, then power m, and m here m minus 1, so we can take like m minus 1, see, so it is proved here. Now question number, this is 30. G of G dash x equal, this is the first formula, first principle of limit, and this is the G dash x equal to limit x tends to 0, G of x plus h minus G of x by h. Actually from this relation, it is given that the G of x plus y equal to G of x into G of y. So we can write here G of x into G of h minus G of x. And at 0, we put here 0, so 0, G of 0 taken common, and G of h minus 1 by h, and G of 0. From, if we put here G of 0, and this is never be 0, so that's why we take a common, G of 0 not equal to 0, G of 0 is equal to 1. Okay, G of 0 doesn't satisfy this equation, so G of 0 is here 1. If we put here G of 0 is 1, then we get limit h tends to 0 G of h minus 1 by h is equal to 3. It is given, it is proved. Okay, now we have to find the G dash 5 here, G dash 5, and given that the G of 5 is 2, so that's why if we put here G dash 5, 5, 5. Okay, so from that we can apply these rules. G dash 5 is equal to limit h tends to 0 G of 5 G of h minus 1 by h, and taken common G of 5 here, and this is from this equation we get here 3, so substitute here is 3, and G of 5 is given that 2, so 2 into 3 is 6 here. Okay, see the solution of 30. Okay, and now 20. This is 20, x is equal to a sine 2 phi and 1 plus cos 2 phi, and this is a by 2, and this is 2 sine, and this is 2 phi and sine and 4 phi. Apply the multiple rule. Okay, and dx and d phi is equal to a by 2, and this is here 4 into cos and 2 phi, and also 4 into cos and 4 phi. And now y is equal to a into cos of and 2 phi, and this is 1 minus cos 2 phi, and a by 2, and this is here 2 into cos 2 phi minus 2 cos square 2 phi. So this is here a by 2, and this is 2 cos 2 phi, and 1 minus cos of 1 minus 1 minus cos 4 phi. Okay, and differentiate dy and d phi, and this is a by 2, and this is minus 4 sine 2 phi, and this is 0, minus minus plus and sine, and this is also 4 into 4 phi. Now find dy and dx. This is dy and d phi by and dx and d phi, and that is equal to here a by 2, and take a common 4 here, and this is sine and 4 phi minus sine and 2 phi, and whole divided by a by 2 into 4 here. Okay, and this is the answer. This is cos and 4 phi plus cos 2 phi here, so these two are cancelled. So apply the product rule from 3. Okay, 2 into cos of 3 phi into sine of phi, and this is from 2 cos and 3 phi and cos of and phi, and this is and tan phi, and this is y1, so 1 plus and dy dx actually whole square. This is 1 plus, and this is 1 plus tan square phi, and this is sec square phi. Okay, see, it is proved. Okay, see carefully of this solution. Now okay, next problem is that 24. This is there and 24, and this is there cos inverse root over x by a plus x and actually dx. So let x is equal to a tan square theta. So dx is equal to a 2 tan theta and sec square theta and d theta. Actually apply this rule cos inverse, and this is root over of a tan square theta and a plus a tan square theta, and this is twice a tan theta sec square theta and d theta. So this is cos inverse sine sine theta and twice a and tan theta sec square theta, and this is d theta, and this is actually pi by 2 minus theta, this is here 2a and tan theta sec square theta and d theta. This is 2a, we apply the product rule, this is pi by 2 minus theta, okay, and this is tan theta sec square theta and d theta, minus, as if we differentiate this with respect to theta, this is minus 1 and integrate of that. So see, this is tan theta and sec square theta and d theta, and that is equal to tan theta and d of tan theta. This is tan square theta by 2. So actually if we integrate this, we get here tan square theta by 2 and d theta. Okay, now this is twice a. Apply the rules here, twice minus this, and this is actually tan square theta by 2 minus minus plus, this is half here, and this is here sec square theta minus 1 and d theta. Now twice a, and 2 are cancelled, this is pi by 2 minus theta, and this is tan square theta, and this is here a, and this is tan theta minus theta plus c. So this is a into pi by 2 minus theta, and let us assume x is equal to a tan square theta. So tan square theta is equal to x by a. So tan theta is equal to root over x by a. So we can write theta equal to tan inverse x by a. So theta is equal to tan inverse x by a, and tan square theta means this is x by a. So here a cancel. So a means and tan theta means root over x by a, and theta means tan inverse root over x by a and plus c. Okay, see, this is pi by 2 minus tan inverse root over x by a. Sorry, this is x, and if you multiply a, then we get ax minus a into tan inverse root over x by a plus c. Okay, I think all of you are better understood. This is a very interesting question. See the 24. Now 26. This is 26, and this is 25. This is 25. This is x to the power 4 minus 1 by x square root over of x to the power 4 x square plus 1 and dx. For this, factorize this as x square plus 1 x square minus 1 dx, and now x square, and take a common x square. Actually we want to find like that x square plus 1 by x square plus 1. Actually ddx of if y is equal to x plus minus, so it will be a x plus, if we get x plus then 1 minus 1 by x square. If we differentiate x minus 1 by x, then we get here 1 plus 1 by x square and c, and so that's why we divided by x square on the this factor, then we get here 1 minus 1 by x square dx. So from that, so and dy equal to, and this is dx. From that we can put here y, and divided by this part as a x plus 1 by x we get here, and now from this we can write here as x plus 1 by x whole square minus 2 plus 1, this is minus 1. So substitute this, and this is dy, this is y, and this is root over y square minus 1, and let y square minus 1 is equal to z square, and if we differentiate dz, we get dz and twice y and dy. So this is 2 or 2 are cancelled, so this is z and dz, and this is z cancel, z plus c, z means root over of y square minus 1 plus c, and this is x plus 1 by x whole square minus 1 plus c, and we get here so this is actually x square 1 by x square plus 1 plus c, and this is your answer for this. Okay, now see the next problem. See the next problem, that is 26, and 26, and this is your integral toward tan x and dx. Let y square is equal to tan x, and this is twice by and dy sec square x and dx. So dx is equal to twice by and dy 1 plus tan square x. This is twice by and dy. Tan square means 1 plus y to the power 4. So this is dx. In place of dx, we put here 2y dy by 1 plus y to the power 4. Okay, and tan y is here y. Okay, tan root tan x means y square is y. So this is 2y square and dy, and this is y square plus 1. Sorry, y to the power 4 plus 1. Now put here y square plus 1, and this is here y square minus 1, and this is dy by y to the power 4 and plus 1. Now see y square plus 1 by y to the power 4 plus 1 and dy, and this is here y square minus 1 and dy. This is y to the power 4 plus 1 divided by y square. Then we get 1 plus 1 by y square, and this is dy, and this is y square plus 1 by y square, and c divided by y square, then 1 minus y square. And this equation, these two formation are same pattern, y square plus 1 by y square here. Now see, and this is the differentiation of y minus 1 by y. So that's why we can express in the form of minus and plus 2, and this is the same as y plus 1 by y. So it can be expressed as a plus pattern. So minus 3 and minus 2 and whole square and root 2 whole square. Okay, and this is 1 by root 2 and tan inverse y minus y by root 2, and this is here 1 by 2 root 2 and ln y plus 1 by y minus root 2 by y plus 1 by y plus root 2 plus c, and where and y is equal to root tan x. Okay, I think we are all a better understood. And see the next question. Here is 27. This is dx by x into x to the power n plus 1. Let y is equal to x to the power n plus 1. So dy is equal to n into x to the power n minus 1 and dx. 1 by n dy x to the power n minus 1 and dx. As we see, this is x to the power n minus 1. So multiply numerator and denominator part by x to the power n minus 1. Okay, and then we get here x to the power n. So x to the power n plus 1. So substitute that 1 by n and dy, and this is here y and y minus 1. Okay, and from this we can express as a partial fraction. This is y 1 by 1 minus 1 and minus 1 by y and dy. If we take a LCM, then we get this and 1 here. So this is perfectly separation I've done here, y minus 1, and this is 1 by y and this is dy. So 1 by n, and this is ln mod y minus 1, and this is ln mod y and plus c. See, this is 1 by n and ln mod of y minus 1 by y and plus c, and this is 1 by n and ln y minus 1, and this is x to the power n and by y, and this is x to the power n plus 1 and plus c, and this is your answer. Now proceed to the question number 28. See, most interesting question is this, and also this is, and also the question number 28 here. Now see, and this is 28 and dx by, and this is 3 plus and 2 sin x and into and plus cos x. From that the degree of sin x and cos x is 1. So we can easily substitute the geometrical formula of sin 2x in pattern of tan, and this is a 3 plus 2 into 2 tan x by 2 and by 1 plus tan square x by 2, and also for cos, and this is a 1 minus tan square x by 2 and 1 plus tan square x by 2 here, and take a LCM, then here 1 plus tan square x by 2 and dx, and this is a 3 plus 3 tan square x by 2 plus 4 tan x by 2 and 1 minus tan square x by 2. Let, and this is a 6 square x by 2, so y is equal, if we take a LCM, tan x by 2, and so, and this is dy half into 6 square x by 2 and dx. So now see 6 square x by 2 and dx. See, this is 2 tan square x by 2 and plus 4 tan square x by 2, and 3 plus 1 is 4 here. So see, and if we take a common half, then half 6 square x by 2 dx, and this is here tan square x by 2 plus 2 tan x by 2 plus 2. So this is and dy, and this is y square and 2y plus 2, and this is dy, and this is dy y plus 1 whole square and plus 1, and so tan inverse, this is y plus 1 plus c, this is tan inverse 1 plus, and this is tan of x by 2. Okay, y means tan of x by 2 plus c. So for this is the 28. Okay, see carefully. Now follow the 29. And this is 29 here. This is 0 to 1 half and sin inverse x and dx all divided by 1 minus x square whole to the power 3 by 2. Okay, let x is equal to this is sin inverse, so you can take here sin theta and differentiate this dx equal to cos theta, and this is d theta. So from that, if we put 0 here, so limit of theta is 0. If we put here half, then the value of half, that is sin 30. This is 30 pi by 6 here. So sin inverse x is equal to theta, and d theta means dx means cos theta and d theta, and whole divided by 1 minus sin square means cos square. Cos square whole divided by 3 by 2. Okay, and this is equal to 0 to pi by 6 theta cos cube theta d theta, and this is equal to theta and 6 square theta and theta. Now integral theta and 6 square theta and d theta. This is apply the u into v method. D theta minus d theta with respect to theta. This is 6 square theta d theta bracket close and d theta. This is theta tan theta minus 1. This is tan theta and d theta. Theta tan theta minus log mod sec theta plus c. So therefore result is theta tan theta log mod sec theta, and this is 0 to pi by 6. This is pi by 6. Tan 30. Tan 30 means 1 by and root 3 minus log of and cos 30. Cos 30 is equal to root 3 by 2. So sec 30 is equal to 2 by root 3 here. Okay. So this is 2 by root 3. And this is positive value, not negative mod sign. Okay. Okay. This is the answer. If we put 0, then this is 0, and sec 0 is 1, log 0, log 1 is 0. Okay, I think all of you better understood. See this video.